Today we are diving into one of the cornerstones of modern software development – object-oriented programming, or OOP. We'll look at how it became so widely adopted, the role pioneers like Alan Kay and Smalltalk played, and why some folks still prefer alternative styles like functional or procedural. Object-oriented programming traces its root back to Simula in the 1960s, but it truly took off with Smalltalk developed at Xerox PARC. Let's have small talk about Smalltalk. Smalltalk is based on the idea that everything in program is an object, and that these objects communicate by sending messages to each other. When one object wants something from another, it sends a message: some object, do this. And the receiving object decides how to handle that request. This approach fundamentally shaped how we think about modularity, encapsulation, and the interplay between different parts of a software system. During the 1980s and 90s, there was a philosophical shift in how programmers thought about software design. Procedural languages like C and Pascal were dominant, but then came C++, which fused C speed with OOP. This era saw many developers move away from purely procedural code to adopt these new object-based methodologies. Alan Kay once said, "The best way to predict the future is to invent it." His vision for Smalltalk was not just about classes and objects, it was about message passing, encapsulation and modularity. He believed software should be built around communicating objects, much like cells in living organisms. Here are the key principles of object-oriented programming. Encapsulation. Think like having your phone in a protected case. Everything that makes it work, the data, the functions, is safely tucked away inside. Nobody else can mess with it unless you allow them to. It's your all-in-one package that keeps everything neat, tidy, and shelved from random interface. Inheritance. Ever learned something from an older sibling or a friend and then build on that knowledge for yourself? That's inheritance in a nutshell. You take an existing class like a blueprint and then add or tweak it for your own needs, so you don't have to reinvent the wheel every time. Polymorphism. This one sounds fancy, but it just means that different objects can respond to the same message or function call in their own unique way. It's like saying start the music and one friend pulls out a guitar while another hops on a piano. Same command, different actions. Abstraction. Life's complicated, so we focus on the important details and ignore the rest. That's an abstraction. If you're driving a car, you just care about the steering wheel and pedals, not the entire piston's design. In code we do the same, only show what others need to see and hide the rest, all the complexity under the hood. OOP promised better organization, code reusability, and easier maintenance, all crucial as software systems grew in size and complexity. Smalltalk was elegant but remained somewhat niche. C++ brought OOP principles to a broader audience, leveraging the popularity of C. Then came Java in the mid-19s with its "write once, rhyme everywhere" philosophy, making OOP even more accessible. Today, languages like C#, Python, Ruby, and frameworks like Spring or .NET rely heavily on OOP paradigms. Even if they incorporate other paradigms like functional features, OOP remains a mainstay for the structuring large-scale applications. Despite OOP's dominance, some developers love the clarity and simplicity of procedural code. Others champion functional programming for its immutable and pure functions, great for concurrent and distributed systems. Here are some common criticisms of OOP. First off, if you rely too heavily on inheritance, you can end up with really complicated class hierarchies that are tough to maintain. Then there is encapsulation, which is usually helpful, but sometimes it hides so much that you lose track of what's actually going on in your code. Finally, large OOP projects can get out of control if they are not well structured. Some people call this class explosion, because you end up with more classes than you know what to do with. In practice, many modern languages and frameworks allow you to blend paradigms. You might write object-oriented code for high-level structure but use functional techniques for specific tasks. It's all about choosing the right tool for the right job. OOP isn't going anywhere anytime soon. Its concepts are baking into how we build GUI frameworks, web servers, and mobile applications. Yet we are seeing more flexible approaches that combine OOP with functional ideas, especially as software becomes more distributed and data-heavy. So what do you think about object-oriented programming? Do you embrace OOP wholeheartedly, or do you prefer a mix of functional and procedural styles? Let us know in the comments. And if you enjoyed this deep dive, like this video, subscribe for more tech and programming content, and hit that bell icon so you won't miss our next episode. Thank you so much for watching, and stay in tech!